Hello peeps and welcome back to my YouTube channel. In this video, I'm going to be explaining 9.1 using Ronald McDonald's 2 for my pre-calculus class and uploading it to YouTube, because why not? So let's say you're trying to speedrun Ronald McDonald's 2, getting all endings. There are 4 endings. The bad ending, which we'll call B. The good ending, which we'll call G. The secret ending 1, which is the alien ending, which we'll call A, and then the secret ending 2, which is the portal ending, which we'll call P. If you're trying to figure out what order to do the endings in, how many different ways are there? We can do this through brute force, visualizing it with a tree diagram. For the first ending we get, it can be any of them, so we have 4 options. For the second ending, it can't be the ending we got again, so it can be 3 options. Then for the third ending we get, there are only 2 options left, because we've already used 2 options. Then the last ending, there's only 1 option, because we've already used the other 3. So, we can count up the number of lines at the end, and we get 24 different permutations, is what they're called. We can count this as 4 times 3 times 2 times 1. This is actually the same for any size set, so we can generalize it as there being n factorial permutations of an n set. This feeds nicely into the multiplication principle of counting. If a procedure P has stages S1, S2 up to Sn, and if S1 can occur in R1 ways, S2 can occur in R2 ways, up to Sn occurring in Rn ways, the number of ways that P can occur is R1 times R2 up to times Rn. We can use this in a different speedrunning category of Ronald McDonald's 2, where you have to get 4 endings, but it doesn't matter if we repeat some or don't get others. So like you could do all good endings or whatever you want. The first stage can occur in 4 ways, then the second one can also occur in 4 ways, because we can repeat the one we used in the first stage. Third one in 4 ways, and the fourth one also in 4 ways. And using the multiplication principle of counting, that's 4 times 4 times 4 times 4, which is 256 permutations. What about a category where we have to get the good ending 2 times, the bad ending once, and the alien ending once? If we just do 4 factorial, we overcount, and it would count different orderings of the good ending as different. To get around this, we divide by 2 factorial, which is the number of repeats factorial, basically. So in general, if an n set contains n1 objects of a first kind, n2 objects of a second kind, up to nk objects of a kth kind, then the number of permutations is n factorial divided by n1 factorial times n2 factorial up to times nk factorial. But if we only have to get 2 endings with no repeats, we can fill the first ending 4 ways, then the next 3 ways, and then we're done. The answer is 4 times 3, using the multiplication principle of counting, which equals 12. In general, if we have r blanks and objects, then r is less than n, so there are more objects than blanks. And the number of permutations is n times n minus 1 times n minus 2 up to times n minus r plus 1. This can be written in the more compact form, npr equals n factorial divided by n minus r factorial. Put the whole thing up there. But we are still overcounting. Take the comparison between 2 paths of the new example, getting the good ending and then the alien ending, or getting the alien ending and then the good ending. Assuming that every ending always takes the same amount of time, these 2 paths end up taking the same amount of time. So like if the good ending takes 1 minute and the alien ending takes 30 seconds, that would add up to 1 minute and 30 seconds. Either way you do it. It could be 1 minute plus 30 seconds, so it could be 30 seconds plus 1 minute. They both equal 1 minute 30 seconds. Across situations where we don't care about the order, counting the combinations. This is equal to NCR equals n factorial divided by r factorial times n minus I factorial. I'll put the whole thing up there. So an example of a permutation problem is if they let you skip the cutscene of the ending you do last in the get two endings category. If the good ending takes 1 minute and the cutscene takes 20 seconds of that, and if the alien ending takes 30 seconds and the cutscene takes 10 seconds of that, then if you do the good ending first, then that's 1 minute plus 20 seconds, so that's 1 minute and 20 seconds, because that's minus the 10 from the alien cutscene. But then if you do the alien cutscene first, that's 30 seconds plus 40 seconds, which equals 1 minute and 10 seconds. So the order does matter in that case. But if you still have to watch the cutscene, then it's the same thing as before with just 1 minute, 30 seconds, 1 minute. For the final application of the counting principle, we can take a look at the trailer problem. Let's say you're trying to figure out what clips from Ronald McDonald's 2 to put in the trailer. Out of the jump scare, shotgun blast from Ronald, grenade from Ronald, us getting minced, us getting kicked as a patty, us shooting Ronald's arms and head off, us destroying the sign and blowing up the store, us driving away from the cops and crashing, Ronald getting abducted by aliens, and Ronald being stuck in a time loop. We can choose not to include any. And this is just about what ones you want to include, not the order you want to include them in. This would be annoying with the combination formula, as it would be 10 CR calculating it for R equals 0, 1, 2, blah 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 up to 10. An easy way to do this is to consider the 10 options as yes or no statements. We have two choices for each option, yes or no. So if we were to add the jump scare, the grenade, the getting cooked, us destroying the sign and blowing up the store, and Ronald being stuck in a time loop, that would be yes, no, yes, no, yes, no, yes, no, no, yes. By multiplication principle, we can count this up as 2 times 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 2, or 2 to the power of 10. That's a lot of 2's. Which is 1,024. The number of possible trailers. Assuming, as I said before, the order doesn't matter. This is just what you want to put in there. This has a general rule, where there are 2 to the power of n subsets of a set of n objects, including the empty set and the entire set. An application of that general rule is if you're making a video on Ronald McDonald's 2, and you're trying to figure out which of the 4 endings to include, and you can include none, or all of them, or anything in between. That would be 2 to the power of 4, because there are 4 objects in it, which would equal 2, 4, 16. Yeah. That was the video. Hope you guys enjoyed it. Oh, yeah. Wow. Whoa. Yeah.